Finishing up section 8.1, we're going to look at multiplying and dividing rational expressions. So we'll start by kind of reviewing how do we handle multiplying and dividing just regular fractions. So in our first example here we have 3/4 times 16/9, kind of a review of how we handle multiplication of fractions. Well, we have some options. With fractions we can multiply just straight across our numerators and straight across our denominators. However, we then have to reduce, and it might make it easier if you reduce before you go through and multiply. So, if we have a problem like this, we can look at the fraction and look at 3 and 4, do they share any common factors? And look at 16 and 9, do they share any common factors? Neither of those do, though. However, we also can look diagonally. 4 and 16, do they share any common factors? Well, sure. 4 goes into both numbers. So 4 goes into 4 once, 4 goes into 16 4 times, so we can reduce that way. And then diagonally the other way, 3 goes into 3 and 9, so we can reduce. 3 goes into 3 once, 3 goes into 9 3 times. Then we can go ahead and multiply straight across our numerator and straight across our denominators. So if we do that here, we end up getting 1 times 4 gives us 4, and then 1 times 3 gives us 3. So that will reduce to the fraction 4/3. Now if we had a division problem, which works similarly, but we do have to make a change. With division, we can't really divide a fraction by a fraction. What we end up having to do is what you might remember is keep, change, flip. You keep the first fraction, change the division to multiplication, and then flip the second fraction. Okay? So this actually becomes 2/3 times 4/5. And then again, once we have it at this point, we can multiply straight across, unless there's something we want to reduce first. But looking at our two fractions and looking diagonally, there is nothing. So this is going to multiply. 2 times 4 gives us 8, 3 times 5 gives us 15. And if this would have reduced, it would have reduced here before we multiplied, which we already checked, and it did not. Alright, so that kind of helps us remind us about the steps we have to take when we reduce, or when we multiply and divide fractions. So we're going to use those same rules here when we multiply and divide rational expressions. First things first, we always have to factor to see what kind of factors we have in our numerators and denominators, and then we can try to start canceling some things out. So that's the first thing we want to do for sure. It's going to be factor. Okay. So looking at our top expression here, 5p minus 5, well, both those terms have a 5 in them, so we could factor out a GCF of a 5, and that's going to leave us with a p. 5 times p gives us 5p, and a minus 1. Okay, 5p, 5 times -1 gives us -5. Down below there's nothing really to factor, all we have is a p. Okay, times the 3p squared, we could break that up as 3 times p, all over. We could factor out whatever GCF we have here. Both of these terms have a 10, so we could factor out a 10, leaving us with p minus 1. Okay. So at this point, we could multiply straight across and across. However, it'd be less work. Really, if we just remember our rules with multiplying, we can either factor vertically of an individual fraction, or we can look diagonally. Okay, we can do that whenever we're multiplying fractions. So this is nice. It kind of saves us some steps. So I'll probably want to write that in. We can reduce vertically, or diagonally, but only when we are multiplying. just like we did above with the basic fractions. So looking at it right now, diagonally, we have some things we can reduce. Okay, we have a p minus 1 factor here and a p minus 1 factor down here. So that's what I mean by diagonally. Also diagonally the other way, we have a p and a p. We even could reduce the 5 and the 10 diagonally that way. And I'm going to save that for the next step here, just so that that doesn't get missed. So now we want to multiply our numerators and our denominators with whatever is left. So our numerators, we had a 5 times a 3 times a single p. So we have 5 times 3 times p. And then down below, we had that p already divided out, but we do have a 10, and that's all that's left down below. So now we can reduce the 5 and the 10. Okay. So we know 5 goes into 5 one time, 5 goes into 10 2 times. Or you could think of 10 as 5 times 2, and then the 5 and the 5 would cancel out. So now that's as fully reduced as we can get it. Whatever's left will be our answer. And this equals 1 times 3 times p gives us 3p over 2. There's your answer. 3p over 2, or 3/2 p. Okay. So all of these problems are going to work similarly to that in multiplication and division. So next problem, we have all these crazy expressions. We're multiplying them. Well, in order to multiply and reduce, we want to first factor to see what common factors we have. So doing that, well, all of these are k squareds. Well, these three all have a k squared, a k term, and a number by itself. All of them except for this. So those are all where we look for two numbers that multiply to give us the number by itself, that add to give us the number attached to k. So in k squared plus 2k minus 15, that's going to factor into a double parenthesis. So is the k squared minus 4k plus 3. And so is the k squared plus k minus 20. So here, the numbers we want are going to be a positive 5 and a negative 3. Those will multiply to give us negative 15 and add to give us the positive 2. Okay. Here, in the bottom of that fraction, we want the two numbers multiply to give us 3, add to give us negative 4. Those numbers are going to be a minus 3 and a minus 1. Okay, those multiply to give us positive 3, add to give us negative 4. And then lastly, this is a k squared. We can think of this as a 1k. So multiply to give negative 20, add to give a positive 1. That's going to be a positive 5 and a negative 4. Okay. So those three all factor the same way. Then our numerator doesn't have that number on the end. It's just k squared minus k. But both those terms have a k in them. Here we can factor out a GCF of a k. So it's just going to open up a single parenthesis. So k times k gets us back to the k squared. K times negative 1 gives us back to the minus k. Alright, so now we're fully factored. Now we can go through and see what stuff is going to cancel out. So we have a k minus 1 and a k minus 1 diagonally. Those are cancel. Diagonally the other way, we have a k plus 5 and a k plus 5. And then vertically here, we have a k minus 3 and a k minus 3, both in the same fraction. So almost everything dropped out. All that ended up being left is that k up top and the k minus 4 factor down below. As I said, you have to think of this as its own factor, and since you can't factor that any, and this is its own factor. Those don't match, we can't do anything more. That is our answer. K over k minus 4. Alright. So now this next example, we have a division problem. So in order to handle a division, remember we have to convert to multiplication, and then in order to do that we have to flip the second fraction. Okay? So we have to flip this second fraction here. the fraction we're dividing by. And then once we flip that, we can convert the problem to multiplication. Again, it's keep the first fraction, change the sign to multiplication, and then flip. Keep, change, flip. Okay. So now we need to factor all of our numerators and denominators. In order to do that, we'd have to use the divide and slide method here with 5m squared plus 17m minus 12. This is a difference of squares. So we have a bunch of different methods we're going to use. And then this is the one like we just factored. So bottom here, again, this is a difference of squares. And then 5m squared over there, that's going to be a divide and slide. So let me first show you what these are all going to factor into. Just kind of assuming you can do these at this point. We have 5m squared plus 17m minus 12. That's going to factor into 5m minus 3, and then an m plus 4. If you FOIL that back, it'll get you back to 5m squared plus 17m minus 12. Difference of squares. Well, what are we squaring to get m squared? Well, we'd have to have an m and an m. And then 4 times 4 would give us 16. But the difference of squares, we have to have one positive, one negative. Okay, so there's our first two fractions. Here, m squared minus 2m minus 8. What are we multiplying to get negative 8? That adds to give us negative 2. And that's going to be a negative 4 and a positive 2. So m minus 4 and m plus 2. Okay, again, the m and the m give us m squared. Those two numbers multiply to give us negative 8 and add to give us negative 2. And all over 5m minus 3, which will not factor, so we can kind of keep that in its own parenthesis. So now we can go ahead and cancel out our common factors. We have ourselves a common factor of m minus 4 and that m minus 4, those will cancel. M plus 4 and that m plus 4, those will cancel. Top and bottom, m minus 5m minus 3, 5m minus 3, those will cancel. So all that we have left is the m plus 2. And that'd be our final answer. Alright, and this problem's going to get cut off, or this video will, in 2 minutes. So I'm going to really quickly show you how to factor this divide and slide method. So we have to do the a times c is 5 times negative 12, which gives us negative 60. So we want two numbers that multiply to give us that add to give us 17, the middle number. And that's going to be 20 and negative 3. So we write that as m plus 20 and m minus 3. Okay, again, those numbers multiply to give us negative 70 or negative 60, times to get us that, and then add to give us 17. But then we have to divide by the a value, which in this case is 5. So we divide by 5, divide by 5. And that is going to, we then want to reduce. So 20 divided by 5 gives us 4. And then if it doesn't reduce, like here in the 3/5, we slide that denominator out front. So that becomes 5m minus 3. Okay. So that right there is how we factored that top expression and got 5m minus 3 and m plus 4. Okay. That's the divide and slide method. And that is all for section 8.1.